Okay, example 3, you're given a shape, you're given y equal to something. So just now, example 2, you're given x equal to something. So if you're given x equals to something, you see the example 2, they're using method number 2. So example 3 is given y equal to something. And this one is given you a small section there. So again, if this kind of question come out, you only see the blue color. The rest is your answer. You need to, if the question asks you to use method 1, we expect you to draw a small section, horizontal, rectangular. So you can pick any area here. Then you write the center of this small section. You drop down x curly, y curly. So x curly equal to something here, somewhere here. Y curly equal to y. This is equal to x. All right. And you have h and b. So same, the first method you write differential element. Tell me where is your location of your small element. Okay. So the first step you write differential element, then you go to your diagram. You draw the gray color rectangular, dy, and your x, and where is the intersect x and y. Okay. Then the next you write area and moment arm. Again, why we write area and moment arm, because for centroid we derive from concept of moment. So you write area of element. How you get area of this element is b multiply h divided by half. Okay. Or how you get this small area is you take the x multiplied by dy. Okay. Area moment arm, you write area, you calculate dA. dA equal to x dy. And you substitute the x equation. You rewrite this one in this form. Okay, you move your HB to the left hand side, move your B, and you get your X. Okay, once you have your dA, you are using this equation, the integrate dA over dA. How you know you need to use dA? The question mentions centroid of the area. So you use integrate dA. Then the third step is integration. So dy y bar equal to that one. You put inside the dA. It's a lengthy equation. Pull out all the constant value b and h, and you do the integration. On the top, you arrive at 1 over 6 bh squared. Below there, you get half bh. Again, this integration step, you assume you already know how to do. If you don't know, you go to online. There is an open source website, integration steps. You put inside this equation, and it will explain how you arrive at this one. But that one is for the revision. Exam, you cannot use all these tools. Right. So you summarize y bar equal to h over 3. So that's why every time we see a triangular, we always calculate from the base. 1 over 3 from the base. Okay. You already seen this equation when you look at distributed load. Okay. So it tell you determine the distance y measured from x-axis to the centroid. That's why when you measure from y-axis, you are actually calculating, sorry, x-axis is here. X-axis is y bar. Okay. Another one, just now is rod in a circle. Now you are seeing area in a circle. Don't confuse example 1 and example 4. Okay, example 1 is DL. Now you're looking at DA. Same approach. Now you're looking at DA. How you calculate area of a curve is pi r square. Right. And how you calculate a small section triangular, also same. Base multiplied by height, because this is a small section of circular area. So you assume this one is a right angled triangular. So this is a base, this is a height, divide by half. Okay. So same, first step, differential element. You go into the diagram, draw where is a small area of that element. Okay. So this one you read lah. So the centroid of this small element will be at here. Okay, will be at here. Okay. Element intersect the curve at point here. Then second step, you look for arm and moment, area and moment arm. Area moment arm, you calculate area. How you get this area is half base and height. So base is r, height is r theta, r d theta. You'll get r square d theta. Then you calculate from either x or y, because it's a circle. So area you have x bar, y bar. So in this case, it's a circle. All right. So using as a result from 3, centroid of the centroid, this is a triangular. So you know the triangular is half from here, from the base. Right? So it's not half, 1/3 from the base here. So that's why we know that the location of this small dot is 1/3, because we assume this small section is a triangular. Okay, this one we already proved in example 3. Where is the location of the centroid in the triangular? 1/3 from the base. Okay. Then you do integration. Okay. So integration, you have x bar, y bar. Substitute the area that you calculate. Just substitution. Important is the limit here. Some of you might careless mistake here. You will forget what is the value put here. Here is only quarter. So quarter 0 to 90 degree. 90 degree is half pi. Okay. Then the rest you do integration. Pull out all the constant value. 2/3. 2 you pull out. R you also can pull out. Then you summarize the R. Cos d theta. Integrate. All right. Okay. You get x bar equal to something. Y also same. Oh, sorry. This should be typo error. It's not x bar. It should be y bar. Okay. Okay. So same example 5. Now, example 5 is a vertical one, is method number 2. Method number 2. So same, first step, you go for, this is solution. You have two solution. So two solution, this one is, sorry, this one is dx, first method. Second method is dy. Okay, so showing you the first method, but the SOP is still same. Identify where is your differential element, right? So this one is sometimes is given in the question. So this one, if you see this one, means it force you to use method 1. Yes. Okay, differential element. Tell me where is the intersection point of the equation with the small element here. Is at this point. Then where is your x curly, y curly? Then dx. So small element, a differential element at a point of x bracket x comma y. So at this point, and have the height of y for this element. Second step, you go for area and moment arm. Area and moment arm is to find the area. So find the area. This area is what? Dx y. Y multiplied by dx. You get area of this small segment. Okay. Y multiply dx. Centroid at x bar, y bar here. This is a small element here. Okay. Then you have these two. Sorry. This y bar is half from the y curly is half from your y. Because it's you know this is rectangular. Half is always at the half of the rectangular. So your total length is y. Y curly is half y. Then you put inside the integration steps with these two equations. X bar equal to integration of x curly dA divided by dA. Apply for the same y. Put in the equation. Again, you need to know the length, the limit for dx. How you identify? You look at your area. Your area is dx. So you look at your x length. Okay, you look at your x length, 0 to 1. Substitute your dA over there. So before you go to do integration, read back the question, y equal to something x squared. Try to change the y or something that is not related to x term. If not, then this one will become xy. Then you miss out the integration element. Okay. So remember to put in the y equal to x squared here. On the top is x cubed. Below there is x squared. Integrate. Substitute the value. You'll get 0.2 at the top, 0.3 at below. X bar is 0.75. Okay, 3 steps. First, differential element. Second, area moment arm. Third one is in doing the integration. Careless mistakes is usually is the limit, and also you forget to substitute the equation. Okay, this is solution number 1. With this method number 1. Apply for y also. Y here, careless mistakes will be you forget to refer back to the diagram. Here, your y bar, y curly is half y. Okay. So second method, you can see the differences left and right. Second method is the horizontal rectangular. What is different is the location of the first one. You only find the differential element and the location of the differential element. So this is the element. The location is intersect as y bar, y comma x, y comma y here. The center is always at the half of the length here, which is your x half here. So here you know the length is 1 meter. Here to here is x. What is the length here? You take 1 minus x. This is the length here. What is the location of this one? Half of this one. Okay, take this one divided by 2. Okay. Then second step is to find the area and moment arm. What is the area of this one? dy multiplied by this one, 1 over x. Okay. Then you're given y equal to x squared. The third step is integration. You see, the same answer you will get. First, differential element, you only need to find where is it. Tell me where is your element, where is the location of that small element. Then tell me where is the length of that one, referring to x-axis. Then area, dA equal to dy multiplied by bracket 1 minus x. Okay. So your x curly is 1 minus x divided by 2, because this small element, half of that one. Take this one divided by 2. Then this one is your curly y equal to the y height there. Okay. Then the third is integration. Same equation. Applying the a. So the a equal to this one. Substitute there. Then x curly equal to this one. Substitute there. Do integration. You arrive at the same answer. 0.75. You do the same for y. You arrive at the same answer also. It's only the steps is a bit different. Okay. Method 1 and method 2. Okay. Example 6, your homework. But observe the 3 fundamental things. First, you always find differential element. Is it? All right. Second one, area moment, how to find the area of that particular segment. Then third one is integration. Same two equation. All right. dA, because the question asks you to find area. Again, now your test 2 is dl. Okay. Then y a bit lengthy. This is your homework. Okay. So method 2 also same. You observe also same, but arrive at the same answer. This one your homework. Okay, example 3 is 3D. 3D, you know you need to use volume already. Same method also. Okay. So no matter where is what is the shape, the method also same. So you observe where is the symmetry plane. Okay. So symmetry at xy. If you cut xy plane, you see the same shape. You cut zy, you get the same shape. But you cannot cut zx. If you cut zx, you will get two ellipse, two sphere like that. Okay, intersection point is at the two plane, which is y. So your x bar 0, y bar, z bar 0. You only have y. Okay, so you observe, first, still same differential element. Where do you start to look at the element? So look at here. So radius is r. So usually for 3D, we will use r equal to z. Calculate the area. Then calculate the volume of that element. Is pi r square multiplied by thickness. In this case, your r is z. Right? Centroid, tell me where is a centroid, is equal to y. Okay, equal to y. No x bar 0, z bar also 0. Right? Because it's symmetry. Third step, integration, still same, but you're using this equation. Y only see this one and no x bar, y bar, x bar, z bar, because x, z, 0. Okay, the rest is substitution. Area multiplied by thickness, get volume. So here you're integrating with y because you are changing y direction. So from 0 to 100 mm. Okay. Remember to substitute your z equation. Z square equal to 100y. So this is a square root. Z equal to square root 100y squared. Okay. You do substitution and get this one. Okay, so this is how you get. Important, you understand the three important steps. Differential element, area and moment arm, and then you do integration. Okay, these three steps. Okay, no, regardless of any shape you see. Okay. Okay. Then this one also same, but this one, it gives you different density. Application of this question is if you study ocean studies, or is different atmosphere also. Atmosphere. So different height will have different density. So this one, different z will have a different rho or different density. So you know that this one, you are given density, you are using the mass. Leaving mass. So still same. Where is the centroid axis? Symmetry at where? You cut at zy, you look at the same shape. You cut at zx, is the same shape. What else? XY. If you cut XY, not same. You cut XY, density different. Okay, because density is different in Z, so you cannot cut XY. Okay, same. So because of symmetry, X bar, Y bar 0. Okay, because you cut ZX, you cut ZX, ZY. Then you tell me where is the element. In this case, is pi r square multiplied by dz. Okay, at here. Next steps is not area, but because it's 3D, so you're using volume and moment arm. How to find volume? Pi r square dz. R is given 0.5. Centroid at Z location. Then you do integration. In this case, if you're given density, you use mass. Substitute M equal to rho V. Substitute there. Change, all in Z term. Integrate 0 to 1. 0 to 1. You get Z equal to 0.667 at the centroid for this small element. Okay. Okay. So the rest is your homework, right? Homework. Okay. Just now what we study is individual shape. What happens if there are many shapes, like for example, the one that you see on the diagram here? This consists of many shapes: cone, cylinder, and sphere. So how do you find the center of mass, or center of volume, or center of gravity? You combine everything. You do the same. You lock the step is the same. You lock the reference point, and then you do the thing. So for composite body, we will dissect them. We will dismantle them. by keeping the reference XYZ axis. Then you do the same for the parts lah. Okay, so the step is divide, then provided the weight and the center of gravity each part are known, then you do lah. Okay, I'll show you the steps. So the same, this one already seen. If you are composite, then you use W. If you're composite, you use W, because composite, we are more interested in the center of mass, center of gravity, W, or the capital G, centroid. Okay, so this one you read lah. Okay, the rest also you read. This one set for analysis, you read. I keep repeating for all the example. So example 9 will be the centroid. Again, your test 2 will be line and rod. So it can either be in this case or in the more simpler form. But the question will be narrowed down to line or rod. Okay, I cannot tell you which one come out, but I already narrowed down to wire form or rod form. Okay, go and study. Okay, okay, I cannot tell you either it's 2D or 3D. You need to go and study lah. Okay, so locate the centroid of the wire shown. So this one, you have a wire that you know that you can break into 3 different shapes. All right, we call it composite part. So first step to calculate composite body or 3-dimensional body is you break in composite parts. Okay, so try to differentiate this part with the earlier one. Earlier one is individual shape, basic shape, round, cone, all these things. But this one is a combination of many shapes. So first step, you look at the composite part, you break them into 3 segments, like this one. Okay, so what you do in your step, you draw the axis first. You draw the axis X, Y, Z. Then you break the parts into 1 part, 2 part, 3 part, 4 part, 5 part. Okay. Your final exam won't more than 4 part because you don't have enough time. You only have half an hour for one question. Okay, you break into 3 pieces here. Then you label component 1, component 2, component 3. Later, all these things later. Later. Okay. Then you copy the dimension, 60, 40, 20, you copy. This one later. This one later. All this 38.2 later. Okay, first step, dismantle into individual component. Second one, you do like what you learned in the previous class. You do one by one. So composite part, second, you do moment arm. So moment arm, the location of the centroid of each segment is determined and indicate in the figure. The particular centroid of segment 1 is determined either integration or using table. Okay, so you'll be seeing, I think I'll give you, for your test, you will see this table. For your test 2, you will see this table. Okay, so either you use the method previously or straight away you refer to table and refer to each kind of shape and refer to the equation inside the table here. The I is moment of inertia, which is the last chapter. We will cover after Raya or maybe this Wednesday if you're able to finish this chapter today. Okay, so this one, the first one, you refer to what? formula there. Then you need to build a table. After this, okay, first composite part, break them, label 1, 2, 3. Okay. Then determine the location. For example, this one, how you get 38.2, how you get this formula? Referring to table, for example, this one, 2, where is 60? R is 60. 2R pi. How you get 2R pi? Here, a bit smaller, a bit small. So actually it's here. A bit small, but if you enlarge this one, you get 2R pi. Read from here. So this is the distance you get from here. How you get this? How you get this distance here? This is 40. How you get this location? Refer to this table. This is this one. It's half. Okay, half. Where? Yeah, this one is quite easy lah, half lah. Okay. I think I give you the wrong table. There's one more table. I think this one is area. I should give you the volume one. Okay. There's one more table. You can download from the Canvas appendix. There's one table, this one. All right. Okay, so this location is from the table. Then you do this, you need to build this table. Build this table. On the far left, you write segment or component 1, 2, 3. 1, 2, 3, 4. What is their length? Length, you can calculate the circular. This one is pi r square, is total length. Half is pi r. So pi r equal to this length. This one 40 from the diagram. This one 30. This is length. Total length is this one. Then this x curly, y curly is from the table. Okay, so x is half from the reference point z here to here is 60. Okay. Again, this is, I think is you still can use lah, but not very accurate, but you still can use lah. This one still can use. Okay, x bar, y bar, z bar. So this one z curly, x, y, z curly. Z is 0 unless for the third one is minus 10. Go down. Okay, go up positive, go down negative. Go left along the axis is positive, against the axis is negative. So you see the first component is negative 38.9 there because it is towards the y is positive here, is towards the back of the y. That's why negative. So these are the careless mistakes area. This one and this one. Okay, you build L, you build curly x, y, z. Then you multiply x curly with the L, x curly with the y curly with the L, z curly with the L. Okay, you get the value accordingly. Then you summarize the x curly L, summarize a y curly L, summarize z curly L. So you have total of z curly L, y curly L, x curly L, and L. Still back to the equation early, how you find the x bar, y bar, z bar, referring to the equation just now. Change the dw to dl. Okay, same no? X bar equal to takes sum of x curly L divided by total L. Do the same for z. and y. Okay, important. First step, break into different component. Refer to the table. Where is the location of that centroid of that particular shape? Then build this table. Segment L curly XYZ, product of X curly, L curly, Y curly, Z curly, they multiply by L. Find the total, then write the equation of this one. Substitute value, press calculator, then you get the answer. Remember the unit, be careful on the unit. Sometimes give you M, sometimes give you mm, sometimes give you micron. Okay, so okay, this one, okay, any question? No, okay. You do the same, use the same method with any shape that you see. So you see this one, centroid of the plate. This one is area. You know this is area. So you can break into 2 different shapes or even 3 different shapes. You can either this small square plus this rectangular plus this triangular, or trapezium minus small rectangular, or one big rectangular minus this one minus a rectangular. Depend on your combination. Okay? Yeah. So you see, composite parts break into 1 and 2. In this case, I break into 2 component. I minus 1 rectangular. It's like Lego lah. Okay. How you find the location? Refer to table. Where's the coordinate of that particular location? Refer to table. For example, the first one, segment A, triangular. Let me see. Okay, refer to table. For example, refer back. Okay. So if the triangular, you see here, this is the base H, 1/3. Then this one is also got one number here. Square don't have. Square, you know, is always at the center of that particular thing. Okay, depend on all this shape. Okay. After you break into different parts, the moment arm actually is the location of the centroid. This one from table. Okay. Then after that, you build the table. Segment 1, segment 2, segment 3. So basically, these 2 is combined together. You minus this one. Remember, when you minus, there is a minus area there. These are the careless mistakes usually. Okay. So build segment, build area, then X curly, Y curly, in this case, 2-dimensional, no Z. Then you multiply curly with the area, get the total. X bar equal to this one divided by this one. Y bar equal to this one divided by this one. Okay. Then at the end, don't stop here. At the end, go back to the answer. Mark the location of this one in your answer. Don't stop, Okay.
Like, how come the X curly and Y curly, we don't consider them as negative?
This one?
The third segment, yeah.
So this one is the location. The location on the, referring to the, here. We put the negative because, for the area, because we want to remove the area. Yeah. Okay. 3-dimensional also same. You look them as a composite. So this one is, you can say as a cone. Cone, if you look at this shape, there is a sphere, house sphere here. There is either there's a cone shape minus small cone, and there's this one. It tell you there is a radius cylindrical hole here. So this one actually have a hole here. Okay. This is not a good diagram. It should give you the hidden line here. If you study technical drawing, it should show you the hidden line here, so that it show this is a hole here. So basically, how you build this object, you take half sphere, combine with the big cone, you get the total volume minus small cone minus small cylinder. Then you get this shape. So again, you're given the density. Density means you need to calculate dm already lah. Modify the table into dm. Take the total minus the x. Okay. So the rest is same. Only it tell you what is different. Conical is this density. Hemisphere is this density. But it doesn't change the concept. Okay. First step, break them into composite parts. In this case, you have 2 minus this one and this one. Okay, this big cone plus this sphere minus small cone minus small cylinder. Where is the location? This one, the location of the moment or the centroid refer to table. There's an equation there. Substitute value, then minus. Build the table. This one, I should show you this one earlier. This one is the solid object. So these are the center of the G means centroid lah. Okay. So this shape is, for example, this one is this one. So you're having this one. Y is h divided by 4. H divided by 4. So you look at here. H divided by 4. 200 divided by 4, you get 50. This is radius now. This one. Yeah, you have to calculate lah. Yeah. If this question come out, we will give you the height of the cone. Okay, this question not complete lah. I should give you the total length of the cone lah. Okay. Okay, so the rest you build a table. Because this is a symmetry. So symmetry, in this case, x bar 0, y bar 0, only changes is y. It changes in z. So you're using this one. X bar equal to curly w divided by w. In this case, you are given the density, so use convert w into mg. Cancel out the g, you get dm. Okay. So you get this one, dm. So you calculate lah, 1 megagram. You need to convert into mm. This one, you are given the unit of density is in megagram over meter cube. In the diagram you are seeing mm. You need to convert into mm. How many kilogram in 1 meter cube? Okay. Yeah. So you build the table. Segment 1, 2, 3, 4. Mass z, and then multiply the z with m. Get the total mass. Total dm. Okay. Then you calculate. At the end, mark this location in the answer. Okay, with this we conclude chapter 9. Okay, we stop here.